And we're recording. So guys, if it's a day of instruction, the way that we will roll this out is this. I will always give you the topic for your notes. In this case, it's right there on the board, data and measurements. That becomes the title, if you will, for your notes, and you'll write that across the top of your notes. I'll also give you the date. Today is the 25th. If you keep the homework section of your notebook in chronological order, you'll find out that you'll actually better be able to study for tests because you'll have all that pulled together. So Alex, you were asking about like the order of your notebook. The first section will be class notes, and that's where you'll put that. Okay, so guys, I'll give you the topic, I'll give you the date, and then guys, I will always do this. I will spend a couple minutes and I will talk with you about what we're doing today. You understand, and you guys have teachers like this, right? It's like they get up, the bell rings, they get up in front of class, maybe they use PowerPoint, maybe they don't, but they just sit there and read their slides to you, and when the bell rings an hour later, it's over and everyone goes away. You know what I'm talking about? And typically you have no idea what that day was about. Guys, I will always help you organize the things that we're going to go over for today. So guys, here's what we're going to do today. When we get together next week, we're going to get you into lab, and you guys are going to start doing lab work and collecting data. But as you're gathering up data, you need to have some understandings about what types of data exist and how we actually communicate that data. So guys, if you watch my hands, here's the way today's going to work. You ready? You're going to find out that there's two types of data that we're going to work with in this class, and we're going to define both of them and make sure you understand them. Then we're going to get rid of one of them. We're not going to talk about one of the two anymore today, and we're going to spend the rest of the day diving deeper into the one type of data that you need to understand some more things about. We'll break it down one more time, and then we'll turn our attention to the homework that you already have in your possession, and you may have a little bit of time to work on homework today. You guys ready to go? Here we go. All right, so guys, two types of data, right? You've got the title, you've got the date, and here we go. So guys, typically what you'll see is there will still be the same title, and then there will be a subtitle. Not necessary to write that down, but what you do want to write down, and I'll lead you through this, is the stuff that appears in the body of the screen. For example, this. What you're going to find out, as I showed you with my hands, there are two types of data that you are going to deal with in this class, two types of information, and I'm going to give them to you one at a time. So guys, data type number one is this. It is what is called quantitative data. Is that big enough? Can you read that? Yeah, it's not too bad. It's right on the edge though, right? Or is it really okay? Is it okay? I don't know, maybe I'm just getting old. All right, so guys, quantitative data. So let's talk about it. You're all budding young English students, right? So if you look at the word quantitative, what's the root word for the word quantitative? Quantity. So we're talking about how much of something we have. And guys, if you understand that, then this will make sense. If you're talking about how much of something you have, doesn't it make sense that these numbers have got to come from measuring and counting? Doesn't that make sense? That if you're talking about how much of something you've either got to measure it or you've got to count it. And if you make a measurement or if you count something, you will always report that information with numbers. This will always be numerical data. But guys, understand it's not enough to have a number, it's also got to have units. Does it freak you out that I don't have to read my slides to you? And I actually know what's coming up. All right, so guys, here's what you know right now. Quantitative data is data that involves amounts. Therefore, it's got to be measured and it's got to be reported with numbers that have units associated with them. You guys good to go on that? Okay, questions. Now let's do the second type of data, qualitative data. Write it down and then we'll talk about it. So guys, what's the root word of qualitative? Quality, but here's the problem. When you hear the word quality, you're thinking to yourself, quality means like that's quality data, that's really good data, and that's not what we're talking about. When we talk about qualitative data, when we say quality, we mean what are the qualities of this? What are the things that make this true? And so guys, qualitative data is actually derived from observation, and it is descriptive. So it's talking about the qualities of things and not whether or not something is quality. All right, so there you go, guys. Those were the two types of data that you need to understand. Questions on those? You guys good to go? All right, so guys, if you believe that you understand these ideas, that means that you should also be able to apply them. And I want you to do this in your notes because I'm going to call on you, and you don't want that awkward silence where you don't have much to say. So guys, this is actually lifted out of my AP chemistry book. It is actually a computer rendering, and you don't need to understand this, but it's a computer rendering of an enzyme attacking a disulfide bridge in an organic molecule. That sounded complicated, and it is. All you really need to understand is there's white, yellow, and black things and a green thing. So here's what I want you to do. In your notes, please, and if you need to reference what you wrote down, totally fine. In your notes, please write down, given this picture, please write down one qualitative observation and one quantitative observation from what you're looking at right here. And then selectively, I'll call on a couple of you. Hey, what did you think? We'll talk about it as a group. If you're feeling comfortable with it, we'll move on. If there are still questions, we will pause and discuss. So guys, again, one qualitative and one quantitative observation from the picture. You guys good? You need a second. Let's take a swing at this. So guys, let's do quantitative first. Amber, do you mind if I put you on the spot? Is that okay? Okay, so quantitative, right? What was a quantitative observation that you made here? Okay. Stop right there. So there are 6 white spheres in the organic molecule. So guys, with that as Amber's thought, let's talk about it. Is that an example of quantitative data, given the definition you understand? Does it work? What is it that makes it work? First of all, was it counting or measuring? Yeah, she counted. Then think about the way she communicated the data. Did it include a number? 6. What were the units? White spheres. So guys, it counts on all 3 terms. It was a count, it was a measurement or involved counting, it had a number, and it had units. Do you understand? You're okay? Jessica. Jessica, give us a qualitative observation from the picture. Wonderful. And did you notice the overlap there? That Amber said white spheres, and so did Jessica, but Jessica is thinking that that could also be qualitative data. Is what of her observation makes it qualitative? I agree with her that she's right. Go ahead, Cody.
That doesn't use numbers.
It doesn't use numbers, but rather than thinking of it in the negative, let's talk about it in the positive. What in her response would qualify it as qualitative? Go ahead, Alex. Beautiful. And yeah, she described it as being white, but she also described them as spheres. So we had descriptions that would in fact count. Does that make sense? Is that okay? Let's do one more. And guys, I promise you, I wasn't cheering for Mountain View when this happened. He does have a yellow helmet on, so we're at least halfway there. So guys, just pulled this off the internet. I have no idea why, but we've got a coach that is clearly not happy with one of his players. So again, I'd ask you to do the same thing. Qualitative and quantitative observation, just quickly in your notes from this. How'd you do? You okay? So guys, let's talk about this one for a second. And rather than ask for your feedback, let me suggest, because there's probably some common answers. So for quantitative, you probably said things like there are 2 football players. Probably most of you said there's 2 football players. Did anyone have anything other than that? Yeah, go ahead, Kyle.
I said there was a football player in the background.
Let's talk about that. As quantitative, you said that? Let's talk. Would that be quantitative? Wow, that's a fine line. He said there's a football player in the background. Do you understand why I'm a little nervous about that being quantitative? Go ahead, Jessica. The number was the word A. Yeah, I know. That's why I was like, what do we do with that? I think if you had said there was 1 football player in the background, because we do in fact need that number for it to be quantitative. You know what I'm saying? And then, oh, go ahead. And remind me of your name. Sorry. Thanks, Hayden. Go ahead. That's lovely. Absolutely. If you said there are 4 people in the picture, you counted, you got a number, you got units, you're out the door. Is that okay? And then guys, qualitative, you were probably describing yellow helmet, maroon jersey, coach is angry, things like that. Now guys, what about this? Let me offer you one that may create some confusion. You tell me, qualitative or quantitative? So if I were reporting to you and I said the football player's jersey has the number 24 on it, is that qualitative or quantitative? What do you think? Quantitative? Quantitative. Quantitative? Qualitative. But hold on, guys. You got to go back and look at this. It's got a number in the measurement. So if it's got a number in the measurement, how can that be qualitative? And what else? Exactly. So ask yourself this question. Did that number come from measuring or counting? Did I measure something about his jersey that told me 24? No, it's simply descriptive, right? And because that's the case, and guys, this is important. You may want to write this down in your notes. Numbers can be descriptive if they aren't measurements. Numbers can be descriptive if they aren't measurements, and that's important to pick up on, but I didn't fool any of you, so it sounds like you're probably comfortable with that idea. You guys okay? You feeling more comfortable with qualitative and quantitative? Okay, so guys, let's do this. So here's where we're at. Remember what I told you, we're going to have 2 types of data, right? Qualitative and quantitative. What are we going to do now? Get rid of one of them. So guys, we are going to get rid of qualitative. So now for the rest of the day, we are only going to talk about quantitative data. So guys, firm that up in your brain. Quantitative data is numerical data that involves measurements in units. Yes? Because don't let this throw you. And guys, you do want to write this heading down. It'll be a subtitle, but you do want to write it down as the next thing in your notes. So guys, what we're going to talk about now is the quality of quantitative data. And you're going, wait a second. How does that work? How can we talk about the quality of quantitative data? Well, guys, now quality means how good is it? So imagine that I'm going to take a measurement. Imagine that I want to know, I don't know, how tall our tables are. And I get down here and I make this measurement and I tell you that our tables are 71.3 centimeters tall, and I tell you that, and it's quantitative data, and you ask me, are you sure? And I say yes, because I know that this measurement is very, what are the words that we use to describe good measurements? Accurate, precise, specific, correct, right on, whatever. But guys, the thing that you need to understand is we've got all these different descriptors, but there are two that you need to know for this class: accurate and precise. And so guys, here's what you're going to do. In your notes, you wrote this down, right? Skip down 6 lines. Just count them: 1, 2, 3, 4, 5, 6. And then what I need you to do, if you would please, is this: draw 3 bullseyes. They don't have to be very big, like, I don't know, 4 centimeters across, which is about 1.5 inches. So 3 circles, 1.5 inches across, the bullseye in the middle of each one. No, but you've got the answers. Did any of the rest of you print the notes? Nice. What do you think so far? Not bad? Yeah. Have you done this with other classes before? I'm your first. All right, I'm glad I could be there for you. All right, so guys, here's what we're going to do. Accuracy and precision. Now jump up into those 6 spaces that you skipped. And what I'd like you to do is write down the word precision. We're going to deal with this one first. Now, guys, this may seem weird, but you need to know the definition of precision, and I'm not going to give it to you. What I'm going to do is this. And you're going to do this with me. Go down here to the left-hand most target, and underneath that, write down the word precise. Now, guys, here's what I'm going to do. Rather than give you the definition of precise, I'm going to stand back here by Garth, and here's what I'm going to do. I don't really have a gun, but what I'm going to do is I'm going to fire 5 shots at this target. And the 5 shots that I'm going to fire are very, very precise shots. And you'll write them down with me. And when we write down these 5 precise shots, I'll then ask you to write down the definition for what precise means. You ready? So here comes 5 shots. 1, 2, 3, 4, 5. Go ahead and write them down. And guys, those are 5 very, very precise shots. And I never hit the bullseye. So guys, the question is this: what does precise mean? Write down your definition for precise in your notes. Becky, what'd you write down? Okay, what's in your brain? Good. Could we just use the word similar? Yeah, absolutely. I think that's a great descriptor. I've never thought of it that way, but I like similar. What else did you say? Other ideas? Go ahead, Alex. Perfect. They're tucked together. I actually use the word well grouped, which I think is similar to what you're thinking. Go ahead. That's beautiful. Yeah, I love consistent. That's maybe I may actually replace. I like consistent. I also use the word repeatable. I like consistent though, because that's really what we're talking about. But guys, the important thing to realize here is they're not hitting the bullseye, right? If you're a deer hunter and if this is the way you shoot, you're going home hungry. This is what makes deer happy. If you miss single time, you're a happy deer. So guys, understand that while precise is repeatable and similar, it can also be really wrong, right? And so certainly we want to be repeatable, but we'd also like to be right. So now let's talk about right. Guys, next word is accurate. Accurate means right. Let's just write it down. Accurate means correct. So guys, you ready for this? You're not going to like this, but do it with me. Guys, what I'm going to do now is I'm going to fire 5. Is it more dramatic when I stand back here like I actually have a gun? I'll just stay up front. I know, yeah. So guys, I'm going to now fire 5 highly accurate shots at this target. And let's be clear, what are we shooting for? The middle, right? I'm going to fire 5 highly accurate shots. Please write them down with me. Ready? 1, 2, 3, 4, 5. Yeah. Those 5 shots, and I know this because I actually did this on the computer and I could place them very well. Guys, those 5 shots are actually perfectly accurate. Can anyone think through that? How can those shots be accurate if none of them hit the bullseye? Do you see it? What if I did this for you? Oh, you know what? Hold on just a second. I forgot to turn on my writing tools. And so I've got to activate some other software before I can start writing on my board. Just a second. And 5 shots. Okay, I'm all caught up. So, guys, that's gross. Let's do this. So if what about this? So this is what we're, oops, let's go a color that stands out. Red doesn't stand out on red. Okay, so let's go blue. And so that's what we're shooting for, right? Now do you see it? What if I do this? What's true of all 5 of those lines? They're the same length. And guys, if you've taken physics, do you remember the concept of vector sums? What is true of all 5 of these points relative to each other? They all cancel each other out. Now guys, watch this. Let me clean up my mess and watch really close. Don't miss this. If you're not sure what I'm talking about, watch what happens if I bring all 5 of these shots together evenly from all directions. Where do they end up? Exactly in the middle. Guys, what do we call it when we do that mathematically? We are taking an average. And so guys, the deal is this. In order to guarantee accuracy, what we'll do is we'll take multiple measurements and we will take the average of them, and that average will be more likely correct than in any of the individual shots because averages involve more data. Does that make sense? Not bad. All right. So guys, which one's better? Is it better to be accurate or is it better to be precise? What's the advantage of accuracy? It's correct. But as we've seen, to be accurate, we've got to collect a lot of data. What about precise? Why is that good? It's consistent. It's the same thing over and over. So which one would we rather be? Both, right? And so guys, underneath this third target, I'd like you to please write both. Both. That's a weird word when you hear it come out of your mouth. Both. It's kind of yucky. So guys, do this if you would, please. Please fire 5 shots into the right-hand target that are both accurate and precise. 5 shots. Can I show you mine? You ready? 1, 2, 3, 4, 5. Explain to me how I fired 5 shots and there only 1 dot. They're all through the same hole, right? Guys, that's your goal. In lab, when you collect data, you want to be right, and you want to be right every time. That's called accuracy and precision. So guys, let's call time out. We started with the ideas of qualitative and quantitative data. We put qualitative away. Then we learned to describe how good quantitative data is, and we understand that precision means repeatable, or I like consistent, and then accurate means correct, and we now understand that we want to be both. Questions on any of those 4 ideas? You're good? Okay, so now guys, here's what we're going to do, and this is sort of a weird transition, but do it with me. Now what we're going to do is we are going to focus on the word accuracy, correctness. And we are now going to talk about communicating accuracy. include that in your notes as well. So guys, when we make measurements in lab, we want to communicate to our readers how accurate our data is. But unfortunately, we don't get to write a sentence that says our table is 70.3 centimeters tall, and I'm really, really sure it's right. So how do we communicate to the world that our data is accurate? Well, guys, here's the scoop. On this page, on this slide, only write down what comes up in blue, okay? Only what comes up in blue. So guys, watch. Here's what we're going to do. See this? This is actually a thermometer case that I cut down with a hacksaw. And what I can tell you about this is it's about 10 centimeters long. For those of you that aren't comfortable with centimeters, it's about the width of your pinky finger, or at least mine. So guys, what we're going to do is we're actually going to measure the length of this chunk of plastic. And I used to do this in class by holding this up and having somebody make a measurement, and no one else could see it, and it didn't work quite right. So what I did is I actually digitized it. So you ready? Hey, look, it's our yellow chunk of plastic. Okay, and so guys, what we're going to do is this. We are going to measure the length of this piece of plastic. Now guys, in order to make a measurement for length, what do we need? A ruler. Here's your ruler. So guys, what we're going to do is and it's actually this ruler. Let me show it to you. This is the ruler that we're going to use. This thing is broken down into tens of centimeters. So here's 10, 20, 30, 40, and so on. So guys, if we want to measure the length of this on here, what do we have to do? Put them together, right? So guys, the first thing that we've got to do is move this against there. Now we need to make the measurement, and how long is the chunk of plastic? 10 centimeters long. But guys, here's the thing you've got to understand. There's a rule, and it's going to be in blue, which means you're going to write it down, and it's hyper important you understand this. This, more than anything else in the first couple months, is going to kill you on your labs. Write it down. Here's the rule. When you make measurements against a scale, like a meter stick or a ruler, you will always estimate 1 decimal place past the accuracy of the scale. So guys, let me show you when you're ready. Let me show you what that means. Did you get it written down? Once you've written that down, don't write anything else down. Actually, that's not true. No, that is true. You won't write anything else down. We'll try it and see how it goes. Okay, you guys good? So here's what we know. What are the units for this scale? 10, well, centimeters, but tens of centimeters. So guys, watch my hands. So if the units for this are tens, what is 1 decimal place below tens? Ones. Tens, ones, right? So what we're going to do is we are going to estimate to the ones place. So what is 1 centimeter below 10? 9. What is 1 centimeter above 10? 11. So guys, is this chunk of plastic 9 centimeters long? Is it 11 centimeters long? No. So we are then going to report to the world, and again, you don't need to write this down, this thing is 10 centimeters long. Does that make sense? Here's then the question. Can we do better? If we want to know the length of this chunk of plastic, can we do better than using this measuring device? What do we need? Smaller scale, right? So guys, now what we're going to do is we are going to measure the length of this thing with a better scale. So we're going to move our chunk of plastic down, and now we're going to measure the length of this with a better scale. So guys, ask yourself this question. What is the scale of this ruler? It's no longer tens. What is it? Ones, right? 1, 2, 3, 4, 5, 10. So guys, the scale is now ones. So if the scale is ones, what will we estimate to? What's 1 decimal place lower? Tenths. So let's do this. What is a tenth smaller than 10? 9.9. What is a tenth bigger than 10? 10.1. Now guys, this is the take-home message. Is that chunk of plastic 9.9 centimeters long? No. Is it 10.1 centimeters long? No, it's 10. But how do we tell the world it's not just 10, it's 10 and no tenths? What are we going to write down? We are going to write down 10.0. And guys, what does that tell the world? That tells the world that we looked for tenths and didn't find any. Does that make sense? Can we do better? You bet. What do we need to do better? We need a finer scale. So now let's go down to this. This is tenths of a centimeter. So there's 10 lines between each centimeter. So if we go tenths of a centimeter, what will we estimate to? 100. Oh, you guys are getting it. Hundredths. So now, guys, let's bring down our chunk of plastic, and now let's do this. Is this chunk of plastic 9.99 centimeters long? No. Is it 10.01 centimeters long? No. It's 10, but it's not just 10, it's 10 with no hundredths. So what will we write down? Oh, look at you guys. You're learning stuff. It's 10.00. Do you understand the concept? Now, guys, watch this. This is where don't miss the next 90 seconds, because for some of you, it'll change your life. Now I'm going to get rid of the scale. Remember, what we're talking about is communicating accuracy. And guys, I've got some questions for you. Listen close. So guys, here's question number 1. These are 3 measurements of the same chunk of plastic. Guys, here's the first question, and it's sort of tricky. Don't think I'm being weird. Just hear me out. Which one of these 3 numbers is bigger? They're all the same, right? They're all 10. But guys, here's the next question. Which one of these 3 numbers is more accurate? Top, middle, or bottom? But wait a second, they're all 10. So how do you know the bottom number is more accurate if they all have the same value? What tells you that the bottom number is more accurate? Here, let me draw our attention to it. So guys, what in this number tells us that that measurement's more accurate? And where is that information? It's in the zeros, right? Guys, those zeros are not me. I love the word you use. It has more information. Guys, those zeros communicate information. They're important because they're telling the world, I looked for tenths and I looked for hundredths and didn't find any. Does that make sense? Those zeros tell us accuracy. Do you get that idea? So and guys, don't miss this. This is subtle. You ready? So guys, if these zeros tell us accuracy, does that make these zeros important? And I would suggest, don't miss this, I would suggest to you that those zeros are so important that they're significant. For those of you that have taken physics, your head just exploded. Guys, this entire conversation was about significant digits or figures. I don't know what they call it in physics. But guys, that's all significant digits are and do. Do this with me in your notes. Guys, all that, and that's what we're talking about, is what is called significant digits. Write it down. Guys, all that significant digits do is communicate accuracy. So no matter what you learned in physics last year, if you took physics, that's it. If you didn't take physics, you're learning this for the first time, and you're going to learn it well. So guys, significant digits are simply digits that communicate accuracy. That's it. So guys, this then becomes the challenge. You need to be able to figure out which digits communicate accuracy. So guys, how many different kinds of significant digits are there? 5, 7, 11. There's 3. That's it. No matter how hard you made this last year in physics, guys, there's only 3 types of significant digits. If you can keep track of 3 things, you're money. This is not as crazy as you made it last year. So guys, what are the 3 types of significant digits? Write these down. Number 1 is this. non-zeros. You know what? We're not even going to write down the word counts. So non-zeros there we go. Non-zeros. So guys, what are non-zeros? Not zeros. 1 through 9. If you have a digit that is 1 through 9, it will always be significant. Don't write down the examples, just watch. So for example, if we have the number 96, the 9 and the 6 are significant. That's 2 significant digits. If we have the number 61.4, how many significant digits there? 3, the 6, the 1, and the 4. Now guys, what about this? What if we look at 0.52? Is the 5 significant? Yeah. What about the 2? Yeah. What about the 0? We don't know. So what do the other two rules have to be about? The zeros. So guys, which zeros are significant? First of all, these. Final zeros after the decimal. Those are significant. So what does it mean to be final? And you may want to write this down. What does it mean to be final? At the end. You can just write end underneath that. What does it mean to be after the decimal? To the right. You could just write down end and right. And that'll keep you on the right track. So guys, let me show you some examples. It goes like this. We have the number 10. We know that the 1 is significant. What about the 0? Is it at the end? Yes. But is it after the decimal? No. So that would only be 1 significant digit. Now guys, what about this? 10.0. So check it out. Is the 1 significant? Yeah, because it's not a 0. Now guys, what about that 0? Is it a final 0 after the decimal? Is it at the end? Yes. Is it to the right of the decimal? Yes. So that 0 is significant. So now guys, we got to talk about this. What about that 0 right there? Is it significant? We need another rule, because our rule right now would say no, but surprisingly, the answer is yes. And the reason the answer is yes is because of rule number 3. And rule number 3 says trapped zeros are significant. So guys, let's come back to the example and let's look at what we looked at before. We're back to 10. So now let's go. You ready? Is the 1 significant? Yeah, because it's not a 0. What about the 0 on the right? Is it significant? Final 0 after the decimal. Now what about the middle 0? And the answer is yes. The reason is because it's trapped by 2 other significant digits. That's significant, that's in between, so that is trapped. Does that one make sense? So what about this? What if we have the number 8.00035? Are those zeros significant? Because you can trap strings of zeros, they are all significant. And that's it, guys. There is actually a rule number 4 for significant digits, but it's stupid, so don't write it down. The rule is this: nothing else counts. We don't need to know that because it simply says we've covered everything in the first 3 rules. So guys, there's only 3 kinds of significant digits: non-zeros, final zeros after the decimal, and trap zeros. If you can keep up with that, you're good. You good? Go ahead.
If it's not a significant digit or figure, why does it need to be in the number or QT?
That's brilliant. Whoa, what happened to my screen? I am so sick. Look, okay, so guys, some of you log into Skyward, check your grades sort of thing. Yesterday, did Skyward like radically change for you? It looks totally different and behaves different. Did you look, Jessica? They changed the teacher side of Skyward yesterday, and I don't know what they did, but so now Skyward like throws me out like once every 20 minutes, and when it does, it crashes my teaching software. So that's bad. So let's go back to your question. You said if a 0 is not significant, does it need to be there? So let's take a look at this. Imagine that you had the number, let's just go like 1800. Are those zeros significant? Well, let's talk. So are they final zeros after the decimal? They're not good. They are final, but they're not after the decimal. They're also not trapped. So those zeros don't count. So then, guys, the question becomes this. If they're not significant, can we just get rid of them? Well, guys, what happens if we get rid of these zeros? We've radically changed the value of the number. So those zeros can't just be gotten rid of because they're placeholders, and if you get rid of them, it changes the value of the number. Does that make sense? So guys, let's do this. This is completely at your discretion, but we're going to fiddle with this for a second. If you go out and print the notes, you'll notice that in the next slide, we've got a link to a website at a for-profit university called Widener, and this is probably the most boring video game ever. This is the significant digit number generator of science. And if you click here under new number, it will actually generate a number and then ask you how many significant digits. Won't this be fun over the weekend? So, guys, are those threes significant? Yes. Yeah. What about the zeros? Yes. No. No. Let's talk about why. Only two types of zeros, right? Are they after the decimal? Yes, but are they final? They're not at the end of the number, and therefore they don't count. So, guys, how many significant digits in this number? Good, and so you type 2 and check answer, and it tells you right there that you're correct, and that's as good as it gets. So now let's go new number. 2. Oh, what about this? Now let's talk. The 2, the 4, and the 1 count, right? Are those final zeros after the decimal? But are they trapped? Yeah, so that's all 5. Good for you. No, they could also be trapped by a significant zero. So for example, if you have 10.0, final zero after the decimal, that's significant, that's trapped. Is that okay? So let's do this. Oh boy, this is like graduate level. You ready? The 6, and the 5 count. What about those zeros? No, they are after the decimal, but they're not final. What about those? Trapped, so that would be 5. So, guys, what about, hold on, I'm looking for one in particular, but what about that? Do you know what that means? Yeah, so guys, that number right there is calculator speak for 1.4 times 10 to the negative first. How many significant digits are in that? Here's the rule. All you have to look at is this. So it would be 2. So if you're looking at numbers in scientific notation, just look at the part on the left. You get the idea? Questions about significant digits. So what are we going to do with them? Guys, write this down in your notes. This is the last thing we're going to do today. When we're done with this, we're done for the day. This. Write these 5 numbers down. Spread them out across your page similar to the way that I have. Leave a couple spaces between them. So skip down a couple lines. You need a couple lines up here. You need a couple lines between them. This is what you've got to be able to do with these. The thing, I think you'll want to, because that'll be important for what we're going to do with these. Yeah, so guys, and you know what? If I wrote the numbers in parentheses, I wrote them out in words because I found that's a little less confusing at first. If you just want to write the number 4 in parentheses instead of the word 4, that's actually fine. And that's the way your homework is structured too. So guys, as you're writing this down, let me explain to you what we're going to do. We're going to step through these one at a time, and the first thing we're going to do one at a time is figure out how many significant digits are in the number. Then once we've done that, given the quiz that you took last time in class, we are going to round these numbers to the number of significant digits requested in parentheses. That's the take-home message for today. You've got to be able to round numbers to necessary numbers of significant digits. And that's what we'll play with. Are you guys done scribbling? You're okay? Not quite. Are we okay? We're good? Okay, so guys, let's take a look at that number on the left, 314721. How many significant digits are in that number? There are 6. Now, what we want to do, and I would really encourage you to do this with me, we want to round it to 4. So here's what I like to do. Eventually, you won't need to do this. Maybe some of you don't right now, but at least for a little while, try this. What you're going to do is you're going to start at the left and count to the right, and you're going to hit the first 4 significant digits. So the 3 is significant, the 1 is significant, the 4, and the 7. So those are your first 4 significant digits. So that's where we're going to round to. So then how do we round? You guys know the rule, right? 5 and up, 5 and down round, 4 and down rounds down, 5 and up round, you know those. Okay, so the idea is this. So we look 1 past the 7, and that's a 2. So does it round up or does it round down? It rounds down. So we're going to go, I'll do this up here, 314.7. The 2 rounds down. Now here's the question. What do we do with the 2 and the 1? Do we lop them off or do we replace them with zeros? Well, guys, check this out. What happens if we replace them with zeros? They're significant, and now we've got 6. So if we want to do this to 4 significant digits, we lop off the zeros. Is that groovy? Okay. Now, guys, let's do number 2. Well, number 2. So we've got 0001775. So let's talk significant digits. Are these zeros significant? They're not. They are, well, 2 of them are after the decimal, but none of them are final and none of them are trapped. So we've got 4 significant digits. So what we're going to do is we're going to round to 2. So what is our first significant digit working from the left? The 1. And then our next is the 7. So those are going to be the 2 significant digits we will round to. Our next digit is a number 7, which rounds up. So we're going to go 0.00, and then not 17, it's 18, because that 7 tells us to round up. Now again, do we replace these digits with zeros? No, because if we did, they'd be final zeros after the decimal and they'd be significant.
So it doesn't matter how many final decimals, final zeros there are. So if there's 2 zeros at the end, they're both significant.
All of these are significant. They can go on forever. And they would not trap, they'd all be final zeros after the decimal. Yep. I hope I can get rid of those. Oh, good. One more. Okay. All right, so guys, let's do this next one. 8092. Is that 0 significant?
Yes.
Why? Trapped. All right, so guys, we've got 4. We're going to round to 2. So we go 1, we go 2. What does the 9 tell us to do? Round up. So the 0 becomes a 1. So we go 8, 1. But now, guys, we get to John's question. Remember, John was asking about what do we do with zeros that aren't significant? Check this out. Guys, what are we going to do with the 9 and the 2? Do we replace it with zeros? Or do we just get rid of it like we have in these 2? Well, look at what happens. If we don't replace these digits right here, if we don't replace those with zeros, we took 8,000 and turned it into 81. So we are going to replace these digits with zeros because they're not significant. So guys, the basic rule is this. When you're working below the decimal place, get rid of the zeros. When you're working above the decimal place, include the zeros. So now let's go down to our 4th example. How many significant digits in that number in scientific notation? 5. So we've got 5, we want 3. So we're going to go 1, 2, 3. What does the 2 tell us to do? Round down. So we're going to go 4.36. Do we replace those 2's with zeros? No, because they're after the decimal. And then we go 10 to the negative 5th, and we're out the door. All you got to do is keep the exponent form and just write it down again. Groovy? Okay, now check this last one out. This is interesting. How many significant digits are in that number? Are the zeros significant?
Yes.
Both of them. And guys, the reason they're significant is because the 8 and the 7 are significant, and both of them are trapped.
So even though it's separated by the decimal?
That's the point. Even though they're separated by the decimal, they're still significant. So now, guys, we need 3. 1, 2, 3. What does the 7 tell us to do? Round up, and we get 80.1, and there's our 3 significant digits. What do you think, gang? Please. No, because look at what happens if we did. If we put zeros there, they'd be significant because they'd be final zeros after the decimal. Is that okay? Here, because notice where the decimal point is. Here's the decimal point, and if we add these zeros below the decimal, they're significant. Here, the decimal point is here, and those zeros are above the decimal, so they're not significant. Is that okay? Play with them. If you're not sure, I'd love to sit with you. Okay, so guys, grab your homework and let's talk. This is due on Tuesday. Your homework will always be due the next class period. Here's what you're going to do. Oh, and by the way, I should tell you, you guys are grabbing this packet going, seriously? This is my homework? Guys, this is the entire unit's homework. Okay, so look, you see the number 1 at the top? And it goes front and back. And then the next page has got number 2. That's next time's homework. Actually, not next time's, but the time after. Then, guys, the next one is assignment 3. That'll be later in September. And then you've got the study guide for number 4. So, guys, this is your entire unit's homework. I'll always give it to you a unit at a time. So go back to page 1. You'll notice the assignment's double-sided. Go to the front. So guys, notice that the first page at the top, it says determine how many significant digits are in each number. How many are in 71? Write it down. Let's go down one more. Are those zeros significant in 5651.00? Yeah, they're final zero, and so that would be 6 and so on. Now guys, go down to the bottom part of this. Notice what it says. Rewrite the numbers above representing the requested number of significant digits. So guys, for example, the number was 71. Now when you come down in parentheses, it's got a 1. That means round that to 1 significant digit. So what is 71 rounded to 1 significant digit? 70. Write it down. So guys, the next example that we have is 565100, and down below it says round it to 2. So we've got 1, 2. What does the 5 tell us to do? Round up, so it would be 57. And then do we replace the 5 and the 1 with zeros? Or it would take 5700 and turn it into 57. So that would be it rounded to 2 significant digits. Please. Good, Alex. Yeah, I was scrambling to find where you were looking at. But yes, further down that column near the bottom, that would be all 5. You got it. Is that cool? Okay. Now, guys, notice there is a backside to this that is actually where you're writing some things. It's all about accuracy and precision and stuff, and that'll do you. So, guys, here's the scoop. We are on an assembly schedule today, so sadly you don't have 20 minutes to work on your homework, but you do have 10. So this is the way this goes. You're welcome to work with people around you, but guys, this is going to be productive time. If you want to grab your phones to check your answers as you go, you're welcome to do that. If you prefer to study with music, you're welcome to put in earphones so long as we can't hear them. And if you don't have a phone to check your answers, I will always put them on the wall. So guys, we've got 10 minutes. If you're packing up right now going, we're done, I'm ready to go, you don't get it. This is 10 minutes to work on your homework, and I think you may get most of this done in 10 minutes. Anything that you don't get finished, you'll do at home and you'll bring it completed on Tuesday. Guys, dig in. If I can help you, I would love to, and we'll go when the bell rings.